Okay, try again. 407, trapping rainwater 2. Given an m by n matrix of positive integers representing the height of each unit cell in a 2D elevation map, compute the volume of water it is able to trap after raining. Bottom m and n are less than 110. The height of each unit cell is greater than 0 and less than 20,000. Okay, consider this map. Oh, man. Oh, so it's like a 3D version or 2D version of a height map. I feel like I've done this before, though. Not this one, but like I've actually done this in real life because back in the day we were playing with maps. Uh, hmm. Wow. M and M is less than 110. Okay. And each element is less than 20,000, which you could almost discretize. Wow. But a lot of people like solving this one. 861 plus. I should have used the bathroom first, though. But, well, I mean, if this is the hardest problem, then maybe it is a bad idea. I could reuse top. Hmm? Not sure what that means. Oh, geez. Oh yeah. Also, if y'all haven't been here at the beginning of the chat, look, there's an emoji now. Don't know how that. I don't know how that works actually, but I don't know how. I still don't know how Twitch works. Not a. Never really look into it, but I mean, conceptually, this is very easy to understand. I think everyone agrees with that. But the question is, like, what's a clean way of doing it, right? Like, there's gonna be some weird, like, breadth search e stuff. Maybe even in bind. Can you do binary search? Or does it help rather? Hmm. Yeah, that's what. Yeah, exactly. So, that's why I'm thinking of in terms of binary. That's what I mean by binary search. Like, can I like, instead of doing incrementally? Yeah, but I mean, I think like this is also one of those problems where like in the theory it's not that hard, right? But like it's gonna be so many edge cases and hmm, like you have to calculate the boundary first, and then you have to calculate what's inside, and then you have to make sure that all your searches are kind of on the same level. Uh, this actually reminds me a little bit of, but not in a easy way, like one of those the game Go, the board game Go, where you have to like surround them, and then you have to remove stuff that's inside, but not really, or something like that. But it's not. Yeah, it's just very hard programmatically, right? Like we could, I think like the algorithm part, everyone has a general idea, like, and it's just all about the edge cases. All right. With that note, I'm going to use the bathroom then. If I'm going to solve this, I don't think I could do this very quickly. I'll be right back. Oh, Jesus. Wait, really? The 2D one? Uh, I guess I should practice that then. Because you never know. But, I mean, it's not impossible. It's just very annoying. Might as well. Okay. Hmm. I think for each, I'm just trying to also think a, a slick way, or a easy to implement way to kind of figure this out. And okay, so we could, and each of them is greater than 0, so we could treat the boundary as 0. So I think that's what I'm going to end up doing. And then just for each one, just for here, what is my, how do you declare boundary? Oh, it's only 110. Can I? So my thought is like, well, what does it mean to be contained when you do it when you're in the middle of a depth first search? It means or the or breadth first search or just search. So it means that yeah, so you do a depth first search and then you just look at the smallest. Like, how does it take account of one? Because it just leaks, right? Yeah, I mean, I think I'm just also just trying to think about like what does it mean to be contained. Um, but like, how does it know that that's when to stop? And then just go. I guess if it doesn't reach the boundary, is that right? Yeah. Okay. I mean, I think I'll just do that and do one on each cell. Is that too slow? 10,000 and at that first search. So like that's linear. So that's 10,000 squares. So maybe that's a little slow. So we have to do this. So we have to do this like, I mean, it's still only 100 million. Okay, let's figure that out then. How do I start? I guess I'll start by doing something really naive and then figure out how to optimize as I go. And I guess as long as it doesn't reach the boundary, then that's okay. I might actually have this backwards, but that's fine. Because it doesn't really matter as long as I'm consistent. $20,000 times 10,000 is 20 million, okay. Yeah, I'm probably just going to do the 10,000. Yeah, you're right. Probably need to be breadth first search. I was thinking initially depth first search, but 10,000 may actually be Stack Overflow area. Oh, I wasn't thinking about max height, but I think you could. I mean, in your case, you could probably do a binary search on the max height, but I'm gonna maybe try to do something a little bit clever. Uh, I think that's the. I think one thing is that in the example, the lakes, if you will, are on the same height, but I think that's not actually generally the case, right? Because you have one that's like, well, even just this picture, you can't see me pointing at it. I don't know why I point at it, but like on the right side of everything, it's just like one unit down. Then you still have the same answer, but it's not the same height. You know what? Oh, say none for now. Oh, it is definitely interesting. Oh yeah, I don't know if I could do this on a live interview, and that's maybe like given an hour or two. uh, or just keep going, right? Is that even right? That's just water at this height. This is hard actually. I mean, well, I guess everyone knew that, but so I'm at the 1. What is the boundary for the 1? The 3, but 2 is still higher, right? Excuse me. And also, I just realized that when someone was using the term "fought fail," that's that's literally maybe a pun. But yeah, I think that's what I'm like trying to think what that means. Like like you definitely like put in a number and then like okay, maybe I need to maybe that's what I need, a binary search. Maybe I can't do it. Isn't that isn't that n times m times n times m or something? Yeah, I had some other ideas, but I don't. Now I'm not sure it's right. It's here you want this to go up to 3. How do you know? Like how do you know that you could also like fill the 2 and not worry about it? You know that's like a mini hole. Maybe that's fine. Maybe I just do the math on the number of cells that are underneath and then just assume that this would already be under that. Yeah, okay. That's probably that idea. Not super sold on it to be honest, but yeah, okay. This is pop left actually. One, two, one, one, two, four. Yeah, then you would hit the boundary and then that first search, or by first search in my case, would just have nothing, and then the answer would be probably nothing, right? Just leaks out. No, this is not the right. Well, that's the height that you want times the space that are affected. Okay. Minimax. And queue it. Also, I don't keep track of what I've seen, so this will actually just run infinitely. Oops. Yeah, that's kind of what I'm doing, but in a different weird way. Yeah. Let me see. Hang on. Oh, this doesn't make sense. There's this minus. There's a 1 1. 2 1 1. Okay. Let's try to do some of the stuff that you said. Assist test. Example. Now I can't find it for all of a sudden. So I'm just looking at the chat and trying to find it. Okay, fine. 3 2. Let's see if this is 1. Then this should be 0. Okay, so that's right. What are some other edge cases? This is like really tricky. Let's just do one with like, what's it, 20,000 on the borders, and then just middle, none in the middle, and then see what happens. So definitely my code is not right. I know there's definitely at least one more case where that's wrong, and it just happens to be right. And actually, I'm going to put that now. With they're all the same height. I should get something that's 4 times bigger than what it should be. Okay. So I have a bug in my code, but I feel like I have the right idea. I just don't. I just have to hash stuff. Uh, this is the same height. Then we've done it before because we do duplicate work. If they're all different, then this would be right. Oh, let me just put that test as well then. And maybe not 0 actually, but because I think 0 is not a routed input. So my code is right, then it will be right on the 4th one, but not the 3rd one, which is fine. Okay, that is true. Because I just double count some stuff. Because yeah. What does it mean to be counted? If it is part of the same set that has the same height width. Okay. Okay. I think that's the only case where that double counts. So let's see. If that's cool. I'll keep that in mind. But, okay. Am I confident enough to submit it yet? I mean, I think in terms of code, it's okay. We'll see if it once time limited. That's the only concern I have, and I'm too lazy to construct big text. Oh, well, okay, and maybe an empty array, which is fair. I mean, I feel like I've been good about testing that today, but maybe not. But maybe not on this one because I was a little whatever about it. I mean, if this works, then I'll explain my solution. But the time limit's exceeded. Oh man. How close am I? Well, 37 to 40. I think this is, I think my code is right, but I need to figure a way to optimize it slightly more. And hope that if this was an insight, then if this is C++, maybe fine. I mean, minus n, where n is 10,000 square, so probably cutting it close. But I was hoping. But yeah, and also maybe with C++, then maybe this is fast enough. I don't know. It doesn't even tell me how, because usually if you just have one test case, it tells you enough. What is this polygraph? So yeah, I don't know. Okay. So I do have to do something smarter than looking at every cell then. An n square thing. It doesn't matter. What's with this? I know this. 35 minutes. My question is, yeah. So this is like the slightly optimized version of the one with the height, but I good luck, Philip. What can I do better on this one? I mean, I need to eliminate a layer of n. So how do you like if I'm one? How can I tell that 3 is the true border and not the 2? Excuse me. I guess code wasn't so bad. I guess I just need to be linear time better, for sure. Oh, it's starting to rain. Okay, well, I think maybe the other way to think about it is maybe same thing as what I did on the last problem, which is instead of thinking about things sticking in the from inside out, I could think about things from outside in. And if I'm trying to eliminate borders, what does that mean? Like if I start from a border, um, hmm, can I okay, maybe how do I mark down to 1 and maybe set it to 3 without. Hmm. Maybe I would do some scan line thing like we did with the 1D trapping water, right? Can, can you? Hmm. Can you do the? Huh. Now that I think about it, can you just do the 1D? Well, thanks. Uh, I still want to solve it. Can we decompose this with the? How did I think about it? I think one thing that can you? Not this weird topography stuff. Because even though you're in this section, things can be low and then that leaks out. Okay, now you can't really. Uh, yeah, I mean, I think the other way to go is just the outside in method. Uh, maybe. But yeah, I'm just now I'm just trying to think about how to formulate it, but yeah, but this is how you would do a brute force one though. That goes the window. Oh, there we go. But yeah, basically, I mean, my description is that for each cell, I just do a buffer search to that height, and then basically you just take like a cross section of that number, which is correct, but there's definitely a smarter way. Is there a hint? Nope, no hints, thanks. Okay. No, maybe. I guess this isn't my submission history, right? So, oh man, I don't have to worry about losing this code, but I agree with that assessment. Times are crazy. Uh, I'm trying to, sorry, hey, man. I'm trying to formulate that as well. But my way of thinking about it, maybe a little bit, is that instead of like marking the inside stuff and flooding out, I'm, maybe I mark the outside stuff as like not good or something like that, and then slowly we'll get to the middle where you just look at it in terms of the borders, something like that. I'm not saying it that well, but yeah. Um, but I'm still trying to wrap my head around what that looks like, to be honest. So that's why I'm not articulating it that well. But and then we start from the lowest first, and then um, hmm, like let's say this is one. Oh, starts at one. What does that mean? Well, hmm. And then one you look at its adjacents, and it's 3 and 4. Okay, well 3 is bigger than this neighbor, so and you always get the 3 first. Okay, well, I think I have a general idea. Then please ask me questions to explain it. If I don't know. Okay, let me try to hack something up, and then I will try to explain it and keep asking me because I have an intuition about it, but I have to really articulate it. But okay, what am I doing? I shouldn't have deleted everything. At least the beginning parts. I think that part is fine. Let's say oh, I no the other way. I have 0 to get the first row, the last row. And double count some corners. Maybe that doesn't matter actually. Okay. Oh, and then we should also X on the Y. I could have made this cleaner. Um, And now we just go through the do this, right? I think that's something you do clean up slightly sometimes, but now if you see now because we prioritize by the lowest height, if you see any on the border, you're gonna only see higher heights, especially in the beginning. But if we have a border, you see say 4. No, 4 doesn't make sense. But if you see 3, okay, I think I have a better intuition about it. Do I have to think about how to replicate it? Like it's one thing to know how to figure it out, and it's another to like, well, if I see this problem again in like 2 months, how can I figure it out? Other than just remembering the answer, which is helpful, but not necessarily sufficient. Excuse me. Helpful. I didn't even put in the queue. Okay. Oh, yeah. The reason why I want to do this is I could. Something like that, maybe. Maybe I'm off by something. Oh, I didn't. Oh no, there's the pen. Okay. Um, that's roughly right, but maybe I'm missing something. Oh, I don't relax the originals. Maybe that's fine. Because then first time you see a dip, that means everything that on the outside is already processed. So this would give you 1 and a 3. So 3, so 2, so that goes in this 2. Now 1, 2. Don't the biggest first. No, that doesn't make sense. Right? So 4, same thing. That's fine. But it's missing this one at 0, 1 or 0, 2. Or 0, 1 and 1 or 1, 0. Huh. Yeah, I mean, that's what I do. I mean, I wrote in a funky way, uh, but yeah, this equation should only happen if height is bigger than the height map or lower than height. But it's missing one relax. Someone should, I mean, one of these edges should hit up 1, 1. I guess I hit up, this one happens first, so oh, so then this happens first, and this hits up this one, so it seems it. Okay, I think I see why this is the case, but I did want to get some on the border first. Did I screw that up? Well, maybe this relaxation doesn't make sense. So now it's getting priority of 1 up in here, but because this got a priority of 1, so it should be priority of 3. Okay, that makes way more sense. Okay, how do I fix that? Obviously, not easy. Help. Yeah, I mean, I think you caught me while I was doing it. But yes, exactly. Um, okay, well, let me see if it works for my big test cases first. I mean, I would say I do like this farm. I don't know if I would have. Yeah, 26 minutes ago. Okay, so it's much faster. Okay. Hmm. Sorry, I'm a little tired. Uh, this one's tiring. Took me 26. I mean, that took me 26 minutes to do it again. So it took me. How long did that end up taking? Yeah, I would definitely explain it. No worries. And I'm going to try to make sure I understand it as well. So I took actually a little bit less than an hour, which is, I guess, okay, but a lot of iffiness. Uh, okay. So yeah, so I think the other way I was thinking about it, so my old solution was one where like we're taking cross sections, so possible at every possible point we try to fill it to that height, and then sum up all the cross sections and chunks to get the answer, but that time limited because that was n times m squared, which I guess for 100 is a little bit big. I mean, I was hoping that would squeeze in. Maybe in C++ is okay, probably not though still, or it'll be pretty tight. I mean, even now I'm pretty tight. So, but the other way I was thinking about it is like instead of like being inside like a lake or what you want to call it, I'm gonna be like, oh, this is my lake. How do I flood fill so that like I don't reach outside? I did the opposite thing where okay, if I'm on the outside, um, how do I? It's not a flood fill per se. The words are interesting, but it basically is like, okay, so we have stuff from the outside. How do we get things in, right? And and the big one there is kind of well, one is that I use the priority queue just so that because I think it makes because you can think about it at like, okay, this is the level that I'm flooding, um, and you start from the lowest because otherwise it gets a little weird, maybe. Oh, that's the way I thought about it. Um, and then once you get into and then I put everything on a border on it, uh, queued in a priority queue, so it's sorted, and then you just keep on going through the bottoms until you reach an inner one. And inner one is going to be the first time because we already put everything on a border in, and everything that's not in the border will be a possible hole or lake or a possible place where you could trap the water. Um, so that means that if you if you're already at a height in which something interior is shorter than it, um, meaning that you haven't seen it yet, but it's shorter than that means that for that space that's inside, everything surrounded is at least that height, right? And everything else is higher because almost like I would say almost like an induction thing. If like it's very hard for me to kind of visualize it, so please bear with me and keep asking questions. I have patience. It's just that the articulation is a little trickier. But if you have an inside square, right? Uh, the first square that is going to be uh, like I say relax in the sense that is like the BFS, not even BFS, but like Dijkstra type relaxation. Like the first, uh, uh, because we do this like sorted by height, the first cell that is going to be the next to the cell that's interior, that's also shorter, it's going to be the shortest of all the neighborhood uh, uh, surroundings, right? Surroundings, if that makes sense. Maybe I could draw some stuff. Uh, but once that's the case, yeah, you count that as that height, which is what I forgot to do for a little bit. But and then you kind of also count that as being quote unquote on the border, right? Creeping in, um, and then you kind of keep doing that, and you always so if you have an interior cell that is lower than a surrounding height, it will always be at least that height, right? Okay, I know I'm not explaining that well. Let me see if I could find a way to visualize it. Uh, hmm, Okay, let me just actually draw some ASCII art at least. Um, okay, so let's say you have something like this, right? Um, so the first few iterations, like, okay, I'm just going to use an X to kind of just like, okay, we execute all these stuff. So we've done all the ones, and ones are clearly, next to stuff that are taller, right? And then now, okay, we just copy and paste a bit. We could contrast it instead of me just writing over. And then now we do the twos, so that this two is okay, on the border, that is, right? So all the twos are kind of just done now, and everything surrounding is bigger, so get that. Okay, this is where it gets interesting, is when once we do three, okay, it doesn't really matter which three get, or in which order even, but so let's just go with this one, right? Let's say, I'm going to use a circle. So let's say this three, uh, so now you're doing this, and you look around, and next to it is a two, right? And in this case, this two is obviously less than three, but it means that because that this is the first time that the two is being added to the queue, that means that on the border, the everything surrounding it is at least three, right? Does that one kind of make sense? That part, because if like I said, it's almost kind of like an induction type thing where if there was a two in the border, then this would have reached already, right? Like let's say if there's a let's say like in a parallel universe where this is actually a two, then this would have happened earlier, and then this would have gotten relaxed earlier, right? And because that isn't the case, by because we sorted and that's like the order we process them. When we have this three, that means when you do things next to it, that means everything that like if there was a way to get to this cell, less than three would have already happened. But because it's three, then that means that everything is now. That means three is like the border of your current cells, if that makes sense. And because of that, well, you just kind of count the difference, right? And since it is two, so you add one to the count because this should be height three. And then now you could think about that as like now you're flooding it from two to three. So you could even effectively change this cell to cell three, which is kind of what we do without changing the height map. No, I guess we have changed the height map, but we add that to we push it to the queue with that, with S3 instead, and now this done. And then now this is your new kind of state for the map. And then now you also priority queuing in some way. It doesn't really matter what. I mean, it could be this one, it could be this one. It's a priority queue, right? Like at least in this case, it doesn't matter. Maybe another palm, because now this is all on the border, right? Now this is your new map. And now let's say you do this one, then let's say you do this one. So this one gets processed as part of like the surrounding things. So then now this gets done, and then now this is a three. And then let's say that you just do these real quick, and then now you do this one, and then same way you just plus two because now you're in a thing, and then just plus two to it, right? And that's it. And then now you keep on processing, and everything is already in the priority queue, I think. So yeah, so that's kind of the. It's not an explanation, but it's a step by step. And yeah, I think it's like. Let me know if that's a okay enough explanation. But but yeah, it's not. I mean, it's definitely not an easy problem. So I mean, I think I don't remember who said it, but I think that um, it's just a very hard problem. On an interview, I don't know if I could do it, to be honest, especially under pressure. Like now, I'm not really under pressure. I mean, I got one solution that it's not optimal, and maybe in an interview, that's what I would have gone with, and that's good enough. Um, I mean, I don't know if it's good enough for a pass, but it's good enough for me in that, like, that's how I could solve it. And I could explain that part too. But yeah, sometimes you just get unlucky in problems if you're in an interview. So I don't know what to say to that in general, even where like sometimes you have bad days, sometimes you have good days, and sometimes your interviewer gives you an insane problem. Sometimes they give you something that maybe not even insane, just like something that you're more familiar with for whatever reason. Maybe you studied the night before and get a little lucky. Uh, yeah, I mean, sometimes that's part of the process. I don't know what to say about that. But for this problem, yeah, so what is the complexity? So it's just m times n times log m times n, I think, because that's the size of the queue. That's the space and time because you do every cell once. Minus some boundary tracking, but that's constant number of times. Um, and yeah, like I said, if you get this other thing, I don't know how to say this one. Yeah, I mean, I don't know. Sometimes it is. I mean, wow. I mean, well, it is just a hard problem. I mean, there's no way around it. I don't know how to justify this one. But yeah, I mean, it's kind of fun, but it's. I mean, I think and the coding is not that bad once you understand it in theory, but that's not it. That's not easy to understand, and I don't know if I could have. I mean, I think the way I came about it is kind of and this also has a little bit of luck on my side as well. Is kind of one thing that I've been kind of noticing for myself, and some of it you have to figure out a way to be self-reflecting about it. Have a way to self-reflect is kind of like one thing I notice when I study and when I kind of like when I don't get a problem right, what am I getting it wrong on? And this happens for sim in a couple of ways, similar things. Um, like in dynamic programming, even this happens a lot more for me, where uh, some problems are not symmetric, meaning a lot of problems in dynamic programming, not maybe not a lot, but at least in these kind of coding things, a lot of problems are symmetric in dynamic programming, meaning you could go forward or backwards. But some problems you can only go in one direction, and very often I forget to go the other that, well, I forget to even think about it in the other direction, and that's something that I'm trying to think like is there a way to kind of do the opposite of what you want to do in a way that gives you properties that make sense. um, I don't know if I don't think that's like a very actionable thing for anyone other than the future Larry, who will kind of look at this problem again, because I'll probably forget it soon. um, but but yeah, I think like sometimes like an analogy would be like you look at a string problem and you're going from beginning to the end. Uh, but maybe sometimes it's easier to think about it from the end to the beginning, right? Especially when you do like rolling windows, some case, or was it not rolling windows, sliding windows, or two-finger algorithm, or whatever you want to call it. Sometimes it's easier to think about it going from left to right. Sometimes it's easier to think about it from right to left. So it's not quite. I mean, this is not quite an analogy, but that's what I was trying to think about how to do, um, with kind of like okay, doing this step for search for each one and try to figure out what's on the border. Like I just couldn't get it right. Like I mean, we were we were here for like I don't know, maybe not that long, but like a good amount of time watching me trying to figure out how to get around that thing about like okay, if I'm in a lake, how do I find out the boundary, right? Instead, I was like okay, let's spin myself in the head around my head, spin the palm on his head. Yeah, not me, the palm. Yeah, spin the palm on his head and be like, okay, what does it mean if we breadth first search or something like that from the outside, right? Um, and that's kind of how I got to this thing eventually. I mean, you kind of watched the tapes, it took me a couple of minutes, so it's not like I was like, oh yeah, that's now it's obvious. And I was like, well, uh, how do you do a depth first search or a breadth first search from the outside, right? And that's how I kind of take a look at this cursed image. And I was like, well, I guess you're, like at the 3, I know that I want to go inside, but how do I want to like, how do I know that 3 is the right level? And then I think from that, I was like, okay, well, if we put something, if we go on a border and like going from the lowest up, kind of almost like filling it up one by one, maybe then, you know, maybe that's how the way I do it. I mean, I was playing around with it, so I wasn't like very confident about it. I think another way of thinking about it is, yeah, like for each cell on the border, you're filling it up to the nearest neighbor incrementally, um, or like kind of. I mean, it's not quite how I express this, but like, but you can think about like, oh, you eliminate all the ones at the same time because, like, let's say the water on the, like, let's say the ocean level, sea level, yeah, the sea level is going to 1, then what does it look like? The sea level goes up to 2, what does it look like? And then so forth progressively, and eventually you can find the hose, and, and I just, and then it's that idea, and then expressing it in code in a way that allows you to code it in a clean way versus like, some kind of for loop that goes through the entire thing the entire time, and then keep track of what's on the outside and what's on the inside or something like that. Yeah. Anyway, I think that's my thing about this problem. Hopefully, if y'all are interviewing, you don't get this one. I think that's a little bit too hard for me, though it's way. I think it's kind of fun, but on an interview, maybe fun is not what you optimize for.